Are we back? Okay. I just full force quit OBS and started it back up, and then it worked. I don't know what that means. That is weird. Whew. But anyway, um, hopefully we didn't miss much. Uh, I was just struggling my way through this loop here. So grabbing literals off of the clause, turning them into variable indexes, find out how they're currently assigned. If they are currently unassigned, so this is, wait, I thought this was the conflict clause. Shouldn't they all be false? What am I missing? Here's the conflict clause. We're grabbing the conflict clause literals. What am I missing? Shouldn't they all be assigned? They all have to evaluate to false, don't they? I'm missing something. Oh, maybe we're modifying things over time. So at first they're all assigned, but that won't always be true. I understand that everything has to be false, but doesn't everything have to be assigned? Two opposite literals given for a variable. I thought a conflict, so here's what I thought was happening. Now let's go back to the solver. Maybe I missed something here, but I thought that we were saying analyze conflict when we got one of these conflict indexes. And the conflict clause right, I understand that not all of the variables in the model have to be assigned, but don't all the variables in the conflict clause have to be assigned? Like, okay, here's where I'm... In order to have a conflict clause, don't we have to get to a place where one of the clauses is evaluating to false? Right, that's what I'm seeing here. So we got, in this case, evaluate the clause if everything is assigned. We only can get false if unassigned count is 0. So everything in this clause should be assigned. I'm going to keep going here with a quick assignment. Now, it's not modifying the assignments in any way. I understand that you're helping Babel, but right now it feels like what you're saying isn't matching with what I see in the code exactly, so I can't use it. Even if what you're describing is the correct way to think about the algorithm, I don't know how to match up with what the code says here. So the code might just be garbage and take me in the wrong direction. I don't want to assume that until I've read the code and built a model of what it's doing in my head. So the code here, analyze conflict, gives me one clause index. Calls that the conflict clause. And it then grabs the clause, and it's doing this loop over them. What I'm confused about is I think... Well, I think it's not possible for this to be unassigned the first time this line gets visited, but I'm going to keep going with the assumption that maybe that's not always true. I'm also going to fix what I perceive as the confusing structure of the code with these early exits in the loops. So this means don't do this. So I'm going to just say, let's put an else around all of this. It means the same thing, right? Now we can do this and it means the same thing. Now we can do this and it means the same thing. Now we can do this, and it means the same thing. So, if the assignment we look at if the assignment we look at has an assigned value, if the decision level is matching the one that we're currently at in the outer loop of the solver, and the antecedent index is not -1. I never really figured out what that part is doing when we're making assignments. So let me approach this in a different way for a second. Here's our model. I want the model to help me out by finding all the places where we do model assign. And there we set the antecedent index. Okay. This is something that I missed before. This might be what connects to what you're talking about. So the conflict clause was one that evaluated to false in the outer loop, but through that we're also going to probably find another clause index that's been called the antecedent index through these assignments. So these get assigned when we're doing unit propagate, and so a variable as the variable gets forced into a particular state. Remember, so the reason variables get forced into particular assignments is because they are a part of a clause where that variable, where only one literal in the clause is indetermined. And since that one thing is indetermined and all the rest are false, to make the clause work, which we have to do, we have to make sure that that particular literal evaluates to true, and so that either assigns true or false to the variable. And then we remember the decision level at which that happened, and the clause index, which is the clause that we used to make the determination that this variable is forced into a particular value. So when we look at an assignment, if we see a clause index that's not -1, that means that that clause forced this variable's assignment. And the decision level tells us how deep into the decision path we were when we made that determination. This case, we're assigning a variable, we're doing it from the variable picker, right? So here, someone's made a guess about maybe setting this variable to true or false will take us down the right path. And so we are not forced in this case by the assignment. Like, there's no clause forcing this. And so here the antecedent clause is -1 because we're saying, no, we weren't forced into this. This is a guess. Got it. Okay. Either way, we know what decision level we made it at, but sometimes we're forced by the clause, and other times we are not forced by the clause. Now, if we get back into here, we're saying, okay, look at the assignments that are, look at an assignment here that is not unassigned. I'm confused about why that is, because I think that they all have to be, but maybe we're just putting in extra checks. And we've got the decision level. I don't know if you might have missed for a minute, Babel. I think I found what you're talking about. I think this antecedent index is passing through a second clause index that I didn't realize before, and I'm getting to the point of realizing that now. So here we can see it grabbing a clause from that antecedent index, and this is the clause that forced this variable this is the clause that forced this variable to have an assignment earlier during the propagation phase. So, now we are looking at it and going, okay, clause resolve. Wait, when did we... I don't actually know what that function does. You must not have read clause resolve. Let's read clause resolve real quick. Clause resolve takes in clause 1 as a raw buffer. I really am confused why they don't just use this guy for both the clauses in the code. It seems like it should work, but it doesn't matter. Clause 1, clause 2. And it's saying, okay, this might be where something interesting happens. I feel like it's going to take these two clauses and it's going to learn something. Because the reason I say it's going to learn something is it looks like right here, we're going to return a newly constructed clause. So I think we're about to learn a clause in this code. That's my guess. So clause 1 count, clause 2 count, total count, rememory copy. Oh, this was another reason why I couldn't build this one. I forgot about this. This is using C's like variable length arrays or something. So like this is a locally scoped array, but its length is variable. And I would have had to like go and figure out how to convince Visual Studio, or maybe I needed a new version of Visual Studio or something. Yeah, there was a couple of reasons why I couldn't get this one to build. But anyways, so we're copying into the all literals from the clause literals, and then we're copying into the all literals from the clause literals of clause 2. So clause 1 and clause 2 just all get smushed together into this new clause. So let me write this down. Say we got here's what the resolve is doing. Takes in two clauses, so we have clause 1 is like this. We have clause 2 is like this. Right? And then it's, let's see, the first step is all literals just becomes a list like this: x1, x2, x3, x4, x5, not x3, right? We just get one of these. Okay, let's continue. Then it sorts them. All right. And yeah, it's just sorting integers here. I assume we're looking at, oh, compare ints A, B. So this is an unusual comparison rule. Let's look at this. We're looking at the absolute value of each integer. I1 is less than, is greater than I2. -1. I1 is less than. weird. Okay, so I think what it's saying is it's sorting by first by the absolute value of the integer. So, -5 is larger than 3 for the purposes of this sorting algorithm, right? Um, and then if I have two that are the same integer up to sign, so I have like a -5 and a 5, then if this is 5 and this is -5, the first one is a 5, the second one is a -5, we return -1, so it's putting the positive versions first. It's like specifically trying to sort this in such a way that we have absolute values increasing and positives before negatives. Okay. So that's the sort. Got that done. Creates an integer array out of clause 1 count. So it creates an integer array like that. Int array create 2 ignored variables. I don't know what that means yet. This is going to be interesting. Okay. Last ignored equals 0. Int I equals 0. I less than total. So total count is how many literals there are combined from the two things here. Check for ignored literals. Literal equals all literals I. So we grab our literal. Get last. Ignored variables. Last ignored. If the array is empty, return a 0. Otherwise, return a 1 and the last. Okay, it's just literally the last variable in the value in the array. So when we do the create on this int array, initial size. Okay, the initial size gives us a size for the buffer, but the array is still empty. Okay, so these here are like size hints. They're not actually saying like create an array of zeros of this size or something. Okay, so do empty arrays with some size hints. By the way, while we're just reading C code and giving comments, this is a part of what I think makes C not great. Like there are things I like about C, but the fact that there's like a tendency to like conceptually, I'm here reading the code, trying to figure out how it works, and a part of what's important about how it works is whether or not this counts as an empty array when I create it, or if it counts as being initialized in some important way. And the C code, the code you actually literally write, implies stuff about what is and what isn't happening. And C code has a culture very often of just not giving that much attention to if when I read the code, I can immediately deduce from what's written here whether or not this is like strongly relevant or if it's like an optimization hint kind of thing. All of this could have, it looks like to me, worked correctly if you just had int array create. It just would have not had these performance hints. But these performance hints aren't being like tagged like, it's not like we're going int array or like, you do like int create with a perf hint, right? Something like that. And then there'd be a clue that this is, that the information here isn't necessarily semantically relevant, but it's just not something people pay attention to. And I think that because that's the way people think of writing C code, it creates the general sense that C code is confusing or hard to get into, because this is genuinely like not, it's not that big a deal, but it's only not that big a deal because I'm comfortable going and reading the source code of every piece to figure out what it's doing, rather than what I think some people would prefer, which I would prefer, that what's implied by this code on the face of it can always be trusted to match what's really going on. And that's just not something you can get out of C code most of the time. You can't trust very often that what's written, especially when it's using functions you haven't gone and read, you can't really trust that it's implying the correct things, which It's difficult to deal with. Anyway, empty arrays, check for ignored literals. Literal, all literals, ret val, get last, ignored variables, last ignored. So if this array is still empty, this will come out with a 0 here, and this will not be updated. I'm gonna have to deal with these continues now. So what this is saying is, let's do it from the bottom. This is saying this. This is saying this. This is saying this and this. Not ret val, or last ignored does not equal. Okay, so if the array is empty, we get a 0 here and we continue. Yeah, the fact that they have all these hidden pointers, like that's this hidden pointer thing here. If this was a pointer here, then you could see that it's creating an int array by allocating a struct called int array, and the fact that it is 2 mallocs instead of 1 is like their weird implementation detail. But you would at least know that you're not being handed a struct. But I think that's what bothers me more. But yeah, this hides 2 mallocs. If I was writing it, I would actually, I would have int array like this, and I would do 2 allocations, but I would be putting it on arenas. So if I get a chance to write one of these, I'm gonna be excited to see, because a lot of times people suggest that the arena programming style only works in domain-specific places where allocation patterns don't get complicated, and I get this impression there's a lot of places like this where you just throw in the arena style that I like, and all this stuff gets so many fewer, it just sorts itself out, is my guess. Hey, welcome, Skayray. Yeah, I'm gonna start. I'm not committing to anything yet, but I think I'm gonna start streaming more regularly. Okay, so check for ignored literals. Get last. Okay, so if we have an empty array, so we haven't ignored anything yet, or the last thing we ignored is different from the literal, the variable we're looking at now. So what it exactly is saying is, yeah, this would come across, if this just was, so here's another style thing. This is making it more complicated than it needs to be in the following way. Get last. Where is this? All right, get last only fills the out value if there is something there. It doesn't want to, because it wouldn't be a correct integer array if when you said get last, it said, oh yes, here's my last value. It's a 0, but it was actually empty. Those are technically separate concepts. But in this case, that's all we need, right? 0 in this case would be a good default. And so what I'm going to suggest is that even if returning something seems incorrect in a conceptual way for this out value, picking a default isn't usually that bad. And 0 as a default is often exactly what you want, because then you can just do this. All right? So now the only way, because the literals can never be 0, so the only way for this to be true is exactly the same set of circumstances, and it's much more intuitive to read, right? Now there's a weird, funny corner case that some people might be like, okay, hold on, won't this become a bug if you ever start using 0 to mean something else and you forget that you're relying on default? And the answer is yeah, this will be a bug in that case. I would guess that if you switch to a case where it's possible for 0 to show up and mean something, that you would have a bug here anyways. even the other way it was written. It would be a more subtle bug, but it would be conceptually not true some of the assumptions that all of this was built around. Even if it was a bug that didn't lead to incorrect results right away, it'd be a bug in the sense that you would write it all a little different if that suddenly became true. Yeah, I'm gonna be streaming. Like I said, I haven't got I haven't got a schedule figured out, but I'm kind of thinking I'll do like once I get into it, something like a beginning of the week stream to do some programming, maybe something like what I'm doing here, something like hard, something hard, and then I'll do an end of the week stream for something fun, which might be like trying out some software, might be programming and hacking something, jamming on something, or might just be like playing a video game or something, playing a video game from someone from the handmade community that I want to check out, or I don't know, just something that I think would be fun. So I'm thinking of doing like a beginning of the week work stream, end of the week fun stream kind of pattern sometime soon. Okay, so if I read this again, what I understand it to mean is we're looping over all these literals in between the two clauses, and if the one we're looking at now is not one that we have just ignored, it's not one that we have just marked as ignored, then out literals are empty, so add a new literal. Wait, what is out literals are empty? Oh, okay. Okay. What they mean is if out literals are, so this here is checking if the out literals are empty. Then we add that literal to an out literal. So boom, that's an output literal. Otherwise, we look at the last output literal. So it's not empty. Then what we do is we look at the last output literal. If the last literal plus this literal equals 0. So this is saying, so here we have something that can't be 0, but can be a positive or negative integer besides that. Similarly, this can't be 0, but can be a positive or negative integer besides that. So if we add them up and get 0, what is that telling us? It's telling us that they are the positive and negative versions of each other. So we have two literals. This is what Babel was telling me was coming sooner or later. We have two literals with sort of opposite valences, but they're the same variable, right? I have a 5 and a negative 5. So two versions of the fifth variable, but one of them is the positive version, the positive literal, and the other is the negative literal. And so if those add up to 0, that's what that means. They're opposites of each other. And we pop that off of the list. Yeah, it's pretty clear how it's a conflict now. The array buffer, we pop one off, okay, and we're ignoring the possibility to read what we popped in this case. We pop that thing off. So this is one of the two conflicting places, and we append it onto the ignored variables. Interesting. Okay. So we append it onto the ignored variables. So now we're not interested in seeing that. Now that's if they equal 0. Otherwise, if they're not the same at all, so we avoid pushing any duplicates. We avoid pushing any duplicates back to back. if and we avoid pushing something and its opposite together into the same list. We say if something and its opposite are both going to go in, we remove them both. What's confusing about this? Oh, yep. I was going to get to that part. Okay, Babel helped me with the last step with his comment there. I was going to say, what's confusing about this is it's like, it's always operating on the end of the list. How is this doing anything useful? Like, yeah, it eliminates duplicates side by side or conflicts side by side, but what about if they're not in order? But they are. We sorted them. That was the first step, right? We took them, we sorted them in a specific way so that similar things, obviously when we sort, duplicates will be next to each other and those will eliminate each other. Those will get whittled down to one copy of itself, but conflicts will be next to each other too. And so while we're like, if we see 555 negative 5 negative 5 negative 5, well, the first those fives are going to collapse down into 1 5, and then the first time we see a negative 5, what's going to happen? We're going to go, oh great, eliminate the 5 and put onto the list of ignored variables the 5. So now the 5 is ignored, and all the rest of the negative 5s that are coming next will get ignored as well, because we're going to go, boom, oh, look at that. The literal negative 5 we're looking at was just ignored, so it's out. And what's left? Well, what's left is one copy of everything that didn't have a conflict in the array. Yeah, you're totally right. You're totally right. Yeah, okay. And with that, it's not even clear, why do we have an ignored variables array? Why isn't this just a single, like why isn't this just an int? Right? Shouldn't this just be an int? Because we can only ever need to be ignoring one. In fact, even if we could ignore multiple things, we are only ever looking at the last one. This is just a variable. They're just using a list as a variable. They're using a list as a variable, but I think they wanted to have the ability for something to be empty as a signal. It was like helpful for them to think of that way, or maybe it's useful for debugging purposes to see. Like sometimes it's useful when you're building a thing, you make it a list because it's easy to think of it that way. And so when you build it that way, it has nice debugging purposes or viewing, but it doesn't actually need to be. If you were trying to make a real tight one, this would just be an integer that you initialize to 0. Anyways, that all makes sense now. Let me make sure to... Alright, so having done that, out clause size. So we built a new clause. Now, I haven't really, while I've read the code, I haven't appreciated the full meaning of this yet. I know that we're eliminating duplicates and we're deduplicating down to one copy of each literal and eliminating conflicts entirely. And then we're making a new clause out of that. So like, what would that mean? Like, let me go over to this. If I had a conflict between this and this, right? So maybe x4 and x5 were both false already. So x3 got forced to be false. But then we found that this clause turned out false. And so we looked and saw like, oh, hey, these need to go. So what happens next is the new clause we get is going to be like x1, x2, x4, x5, right? That's what it's going to look like. And so this is saying these all need to be true, ignoring this. Oh, I see the idea. So like if it's true that we ran into a problem with one of these clauses, and also we have this thing here, then what's happening, then the problem we're running into is whether this is true or false, the rest of this still, like, it's like ignore x3 for a minute. You still have to figure out, you always are going to have to figure out a way to make this true. And why is that? Well, if I... Wait, is that true? Right, yeah. So if, say this part, x1, x2 is false, then we can make x3 true, but then this part will be false, and so one of these will have to be true. Either, so, yeah. If we, let's do this separate. Look at this. Clause 1, why this resolve thing makes sense. Here we go. So we got, like, we'll call it F1 or X. And then over here we have clause 2. It's like F2 or not X. Okay, so F1 and F2 can be arbitrarily complicated formulas for this purpose. X and not X, that's just two literals both referring to the same variable. So what's going to happen is this is equivalent now to eliminating X and having these ORed together. That's what I'm kind of proposing, and I think this is true. I'm making sure. So if both of these are fully false, right? If I said is false, so if this is false, then there's no way to make, right? Then clause 1 and clause 2 has to be false. So if this, then this. Why am I saying that? Well, if this is already false, then this is false and this is false. No matter what I do with X, the and of these isn't going to work because I need X and not X to both be true. So there's no way to get this to work if this doesn't work. So it's not necessarily true that they're completely equivalent, but it's at least true that... Okay, right, okay. So this is an implication, right? We can write it like this. We can say that this is the not of this implies the not of this, right? So just going to use some logical formulas to make sense of this. So if this is not true, that forces this to not be true. But we're in a situation where we can't allow this to not be true. We're trying to figure out a way to make this true. So we take the contrapositive, which is where we flip the direction of the arrow and we flip the negation on both sides, and we get this. So these are equivalent. And so this says, for this to be true, this must be true. So it's not true that our new formula is equivalent, but it is true that if we're ever going to make the original formula true, we would also have to make this one true. Right? In order for this to be true, this one would also work. And so adding this in is like saying we've learned that this is another way to understand the constraints between these variables that does not involve thinking about the variable x. And so now we have, when we go to do, oh, this makes so much sense. When we go to do the variable picker, what's going to happen? There's a new clause, so it's going to weight other variables more. We've decreased the weight of the x variable, and we've increased the weight of all the variables in F1 and F2, so other things will get decided first. And we have a new clause that can force other variables to a certain value over time, so it'll probably mean that propagation works better too. Okay, I think this makes sense. At the very least, I understand how it's not going to be an infinite loop picking the same variable over and over, because as we pick clauses, we are going to be we're going to be creating new votes for the variables other than the one we just picked as ones worth paying attention to next. Okay. So, yeah, this is I'm really happy with both the code and the learning the algorithm. This is fun. There are things about the code that are not great for learning purposes, but that's not what they didn't claim this was for learning purposes. I picked it because it's the best one I could find. I bet you that there's probably better things that are intended for learning, but honestly, sometimes when people write code intentionally for you to learn from it, I don't think that they do it right. Like, I think this is closer to what educational code would look like. Than what I could find if I looked for explicitly educational stuff. I also just think you learn it better if you do a certain amount of figuring it out along the way, rather than like I'm not inventing it for by any means, but I'm figuring it out. You know what I mean? There's a difference between those two things, and figuring it out, it helps me to understand way better than just reading someone's explanation. Yeah, I'm sure that there's good educational material out there. It's just Google search doesn't always the best way to find it, I guess, is another way to put it. So let's keep going. So I've mostly figured it all out. How this code is working. What I haven't done is put it back together in the context of the whole loop. Oh, and there's one other thing. There's one other thing I didn't do. After the conflict analyzer gets the new clause, let's keep going from here. So we get the new clause. I made some assumptions about what's going to happen. I'm assuming the new clause is going to get... the new clause becomes the clause... Did modify clause equals 1. Okay, look at this. Interesting. So we initially were trying to figure out, did we modify the clause? So this is iterative, right? If I come in here and I don't modify the clause, then the outer loop is done. But if I do modify the clause, it's because I found a literal that I could focus on. And each literal that I find produces a different conflicting pair of clauses. So I have one clause that's the root conflict clause. I'm iterating its literals, and I'm finding other clauses that I could resolve with it. And every time I do that, I create a new clause, which lives right here. And then I loop back around and go, oh, I did modify the clause. So now I go again, but now I'm looping over the resolved clause. So I'm iteratively resolving over and over again until I don't find any more conflicting clauses. So I'm glomming more than one pair into this through this iteration. So if we didn't find any conflict, if it didn't do any resolving here, then I suppose that means we reached a dead end, right? We did not find any way to understand we did not find any way to understand. What happens if this returns null? Is that the end of the whole solve, or is that just like a setback? I also don't love that they have these like plugin functions that require me to do this extra step, and they're not even using them, but I'm sure it made sense as a structure at some point for plugging in other things. Okay, so propagate, find a clause that has a conflict, or that doesn't, find a clause that will be the root of our conflict resolution process. Learned clause literals. We then do the thing here if. Look at that. Okay, so if it comes back with no new learned clauses, then that means we've gotten to the point where it's not satisfiable. Why is that? Why is that? I could understand if it said, hey, we didn't learn anything, therefore we don't know how to proceed and we give up. Like, it's undetermined. But this is claiming that if it reaches this state, then it's just unsatisfiable. That this is enough to conclude that it's unsatisfiable. So I want to figure out why that is. So if I come in here and I say, hey, try to resolve this conflict by learning new clauses, why is failure to do that equivalent to there not being a solution at all? At a high level, yeah, Babel is saying at a high level it makes sense. The notion is we have a conflict, we can't do anything about it. But I want to get one level below that and really just see what does that really mean. We can't do anything about it. How does that, where do the dots connect here? So we have a conflict clause. This clause evaluates to false. We need to, well, you know what? Let me do something different here. If figure out the beta. This is the thing I think I want to learn first. I'll figure out how my question can be answered, but first I want to figure out how we do the backtracking. Because here's what I'm thinking. If we can't make progress even by backtracking, then yeah, it's unsatisfiable. But why? How do we know that even backtracking isn't going to get us another path forward? Because maybe we can backtrack and pick the variables guesses differently, right? Wouldn't you'd think like, oh, maybe we didn't find any way to resolve the clause into something simpler, but maybe different guesses of how to assign variables would get us there. And somehow that won't actually be true, but I have to take some time to understand why. So when we do our backtrack, how do we make that determination? We go look at the literals in the clause we derived, and we look at each of their assignments, and any variable that is unassigned or that has a negative decision level, we just skip. I don't know what that means. Maybe you can use a negative decision level to as another way of saying I want to force certain variables into certain values. Like I want to set this to be true and this to be false before you go. And so they're not actually variables. They're just like convenient, a convenient interface into using the model, using the formula. Decision level is greater than or equal to min decision level. Okay, so we're taking a min. We're going across all these and saying anything with a valid decision level, so that's ignoring these guys. These are invalid because they're unassigned. These are invalid because maybe we assigned them in a way that we want them to be considered fixed from the perspective of the solver. Then the rest here is saying, okay, find the minimum decision level. We're going back to a time when when none of the variables in this clause had assigned values. And those assigned values could include assignments from guesses as well as assignments from the propagation of forced assignments after a guess, right? So we take the min decision level, and okay, so if we couldn't learn a clause, interestingly, along the way, I think this is redundant, probably. It's probably impossible. It's probably impossible for, so let's just change a few things. Don't know why people think that these early exit type, it's just I don't mean to like overly emphasize and complain. It's just so confusing to me that people like it. That's all I'm saying. It's confusing to me. So if we have something that is not assigned and the decision level is at least 0, then you are a candidate, and we want to then say if your decision level is less than the min decision level, we do this. So the only way you could get this is if you looked across your clause and everything in it was actually unassigned, which is kind of... Everything in it is unassigned, or there's no place to backtrack to for them. But we're looking at a situation where we started with a clause. Looking at a situation where we started with a clause that was evaluating to false. And so everything in it had to be evaluating to false, which means everything in it had to be assigned at the beginning. And since everything in it was assigned at the beginning, if we get to a point where we've learned some clauses and everything in the finally learned clause is unassigned, that would mean we eliminated every variable and somehow didn't add in any others that were assigned. I don't know why that would necessarily be a problem either, but it does seem unlikely, but I don't quite follow yet. All right. I might need a 5-second brain break so I can take another crack at understanding this last couple steps. Interestingly, the preview on Twitch is working now. I don't know if you folks who are here now were here the first time I launched the stream, but when I first launched, it was working, but I couldn't see the preview for some reason, and now I can. Okay. So, say I've got a variable. So in order for me to get is original clause, the first time we make a new clause, we just set is clause original to false. After that, we start freeing the previous one. You see that we have to do the memory management thing? We're freeing the clause that we made on the last iteration because now we're using another new one. So we only end up creating one clause here. We're not leaking the other clauses. If this never happens, then we came in here, we scanned all the literals in the original clause, and all of them were assigned. Only the ones that are at the current decision level are of interest. Okay, interesting. I think that's important to keep in mind. It's not like it's looking at every variable in the clause. It's looking at variables that have been made, whose value has been set recently. And the reason that's relevant is because if we looked at all of them, we would be sort of resolving conflicts from... So if you're working on a Sudoku and you don't know any good deduction strategies, so instead what your process is to start guessing until you notice that there's a square that doesn't work. And then you unroll your most recent guess. You don't go and unroll your first guess because things you've done since that first guess were only things you guessed sort of in light of that first guess, right? And so you unroll your guesses like a stack. You go backwards. And I think this decision level is enforcing the same kind of thing. We're not going to unroll guesses from too far ago. We're going to unroll our most recent guess. And if it turns out earlier guesses were a problem too, we'll find out later. Hey, welcome Raiders. Hope you're looking forward to reading some SAT code. We're about to switch to a different one, so we're about to start something new with mini-SAT. But I just want to wrap up what I'm reading here. So we know that if we did some resolution, it was a guess from the current level. So there should be one, right? Initially there should be a variable in the clause that's at the current decision level. If there wasn't, then why did we call this, right? We called this after finding a conflict, after making a guess, right? If we go back to the solver, right? The decision level that we passed into analyze conflict is the same decision level that we used when we made the guess, which is this line here. Make a guess, or write our guess into the model. And here, propagate the immediate consequences of our guess. Okay, so conflict clause is, as we're propagating, we found some clause that fully evaluates to false. And then we pass a decision level in here. So we know that there's a variable, at least one, in the clause that we got who's just been assigned, right? At least one. So that's not the good. That's always going to work out. If the one we're looking at is a guess, yeah, this is where I get a bit confused. Like if we look here, this is saying, okay, so we made a guess. We put a guess here. If we're going to do conflict resolution, it has to be with one that's not a guess. It has to be one that was forced. Oh man. So we're looking at a variable. We're saying we did fix this variable, but we fixed it by propagation. So if I'm in a situation where I took a guess on a variable and it made a clause false, and that clause doesn't contain anything that got forced at the current decision level, how does that mean that the whole thing is unsatisfiable? I'm missing this. So there's a piece of this that's, I need to back up and think it through a little bit differently or something. Pick a variable, increment the decision level, make a guess. We do some propagation. I didn't oversimplify what this does in my head, did I? This doesn't do more than I'm thinking. We loop over all the clauses. We evaluate the current clause. If we find a false, we stop right there and deal with it. If we find something that's not a false, but that is capable of being determined, capable of forcing a particular variable's assignment, then we put that assignment in there. And we mark that we did do a propagation. And then we repeat. Yeah. How do I Chat settings. Show mod icons. There we go. And boom. There we go. Took a second, but we got that. Alrighty. Sorry, I had to figure out how to moderate the Twitch with the newest version of the chat system. Okay. Yeah, so propagation is what I expected. This is where we force variables. It seems to me I must be making an incorrect inference from something here. So here I write a guess. We pick a variable and a value for it. We guess that that's the value for that variable, and we write that guess into the model. We then propagate, and these things are things that are now forced logically because of our guess. And maybe, not necessarily, but maybe a conflict happens. When that conflict happens, it's not necessarily true that there was any forced variables. It's possible that the guess itself happened. Wait, no. If the guess by itself, no. Okay, here's the failure in my logic. If the guess by itself created a false clause, then that means that that clause was already very close to being false, because everything in it must be false except for the one thing that wasn't already false but was unassigned. But if that's true, then it would have already been caught. Variables that we make guesses on are unassigned, and if they're unassigned, they haven't been forced, which means when we make a guess on a variable, it can't have been something that should have already been forced into a particular value. So a conflict clause by itself cannot arise until after propagation has added more information into the system. Okay. Cool. And then that means this if we found a conflict clause, we at least know we will find a match here. The clause that's all false must have a variable in it, because yes, we set a variable by a guess, but that variable set, the setting that variable can't possibly have created a clause that evaluates to false. It must have been one of the propagation variable assignments that created this, which means there will be at least one of these in our conflict clause. Once we found that, we can grab that index to a different clause. Yes, that has to be a different clause. Why? If it were the same clause, then that would mean that variable propagation, which forced this variable to take on a certain value, also made the clause evaluate to false. But the whole point of forcing a variable to take on a value is that it's the last way to make the clause true. So whenever a variable gets forced to a particular value, its antecedent index is an index to a clause that evaluates to true. So we have one clause that evaluates to all false, and it contains this variable. Another clause, which must be different since it evaluates to all true, also contains this variable. So we definitely have two different clauses that both contain this variable. And they must be opposite versions of that variable. Like, one must be the positive literal and the other the negative literal, because otherwise they would both evaluate to the same thing. Right? So now it makes more sense that this definitely happens once, but that doesn't necessarily mean that we fully understood. So this, if there was no resolution at all, there should still be a way that that's possible that I'm missing. If this does happen, clause literals, go across the clause, false clause, we have a true clause. when we get this far, we always succeed at resolving the clause and changing it. So I'm not convinced that this is possible. Now, I was originally questioning how we could be sure that if this happens, that there is definitely no way to satisfy the problem. Now I'm questioning that this path could ever be hit, in at least if there's no bugs. Because isn't it the case that to get here, we had to have a false clause that became false by propagation. And as soon as we get one of these, we get a resolved clause and we change from the original. Is there any other way? I just don't think there's any other way. It just doesn't seem like I just don't see it. I just don't see it. Let me go back, just double check that I'm understanding how this plugs into the whole solver again. Yeah, right here we look at the decision. We know there's a conflict clause already. We found it during propagation. The conflict clause, if we picked a variable guess, well, what would this thing look like if it got to the state of finding an assignment that worked? It'd plug in a guess, it runs some propagation, and it would get to the point where all of the variables are assigned and find no conflict, right? If it got to the point where all of the variables are assigned, right? If everything is assigned, but there's no conflict, then we found a satisfying assignment, right? We found a way to assign all the variables to satisfy the formula. So it reaches a failure case. By failure, it reaches proof that the formula cannot be satisfied. Right here. How does that happen? How does that happen? How does that happen? It reaches proof that... So here, I don't see... If we got a literal clause and we looked through... there's something here I'm not getting. Like, is it possible that they're unassigned? And what would be the problem if they were all unassigned? If I learn a new clause and all the variables are unassigned, is that impossible? Is that possible? What it implies... The decision level. I'm not quite there yet. I feel like it must be possible. I feel like it must be possible for the clause to somehow get to a point where there's no way to learn a clause. How? How could you get there? You're looking at the assignments. They all have to be assigned on the first pass. If the decision level of all of them was too small, then this clause was false before this iteration of the outer loop. So that can't be it, right? It can't be that they're all decided earlier. And again, it wouldn't ever be the case that we could make a guess where the guess itself creates a clause that's false, because then that would have been picked up by the propagator in the previous iteration. So no, this always happens, right? Right? This always happens. So it must be something about... I don't think that this can happen. I don't think that that's a thing. Yeah, I don't think that's a thing. I think it's got to be this. We look at all the literals in the clause that we've just learned. Here we're trying to decide how far to back up. And we're deciding how far to back up by looking at variables in the newly learned clause that were decided, and we're backing up to a state where all of the guesses that were responsible for giving them values are undone. If we got a clause that we know, okay, let's keep in mind, we're building a new clause that says two different things. It says the same thing both two different ways, right? It says this statement, which is equivalent to this statement. This statement says if there's no way to fill out this clause that it's true, then there's going to be no way to fill out the original clause so that it's true. It also, the other way around, saying if there's a way to fill out the original, there's some way to fill out this one. They're the same statement. But I'm emphasizing this because if we just learned a new clause, we learn it through this process here, basically, right? We take clause 1 and clause 2 like this and turn them into this, where we eliminate these conflicts, and what we get is the variable that, the set of variables that weren't the same. If I did this, remember this is in an iteration. We don't want to get caught in thinking of this as a one-step thing. This is in an iteration. So if I did this and all of these were unassigned, how could that happen? How could it happen that all of these are unassigned? Well, for that to be true, then we had something in the most recent iteration of the algorithm try to fix x3. So, okay, it can't be that they're all unassigned, because one of these has to be the one that fixed x3. Right? We haven't done any rollback yet. So if we're merging two clauses, clause 2 is always the one that fixed x3. So all of them have to be assigned, because x3 got fixed, so it's assigned, and it got fixed because all the other ones are assigned. So that can't be happening, right? Oh, empty. I should think about that. What happens if the learned clause is empty? That's a good hint. I hadn't thought of that. If the learned clause is empty, that would hit this path. That makes sense. And what makes it empty? Well, it's empty if... Imagine we had a... Let's... Where could an empty clause come from? Question mark. What if we had this, right? So, all of them... if these two clauses both exist in our formula, how will we ever make the formula true? We won't. Why is that? Because, well, could I make that true and that false? I gotta think about this. So in an earlier decision, we guessed things that fixed x1 and x2, and then some one of those eventually that caused, like, from other sources, right? Maybe we guessed these, maybe they were forced from other clauses. But sooner or later, these both came out true, and so this got forced to be false. But then this would be true. This isn't. Obviously, if we had these two clauses, they would lead to this, right? But that doesn't get us there. That's an empty clause would have to look like this. So what if we think about this, like, in terms of how it's an iteration? So instead of looking at it like this, I'll say, like, okay, is this unsatisfiable? Could this be a clause that, or a thing you'd form that would actually not be possible? If they're all true, this is true, but then that has to be false. So x1 has to be false, right? Which means x2 has to, yeah, so this is unsatisfiable. And so if we had something like this, then what might happen is propagation forces x1 to be false, which propagation forces x2 to be false, propagation forces x3 to be false. We then find a conflict, and we go, hey, I found a conflict. All of these just got assigned at this current decision level. So we're going to iterate through x1, x2, x3. We're going to go x1, when did you get forced? And it'll go, oh, I got forced with clause 4. Let's just go through this and see how this happens. So here are our clauses. First, propagation does assign x1 false, assign x2 false, assign x3 false. And then we go conflict. Clause 1 is false. Okay, then we go look at x1, and we see that forced by clause 4. And so then we go resolve clause 1, clause 2, which gives us a new clause, x2 or x3. And then we iterate. And so we go, okay, look at x2. So after we resolve, we get a new list of variables. Those variables include all the things we didn't eliminate from the original clause, plus anything we picked up from here, which we don't care as much about that yet because I don't have an example that shows me what that would be like, but we at least haven't lost any of those original variables, and we've picked up some new ones. I'm not sure what the relevance of picking up the new ones is yet, but let me keep going with this example, see if it's enough to illuminate what's happening. We look at x2. Now that one was forced by clause 3. So that leads to resolve. Let's call this clause new clause 1. So now we resolve new clause 1 with clause 3, and that gives us a new clause 1 looks like this, x2, x3. Clause 3 is x1 or not x2. So now we have x1 or x3. Okay. So this is going to look at x1 again. I hadn't thought of that. That was forced by clause 4 again. This is new clause 2. So we need to understand better how this iteration is whittling down this thing, right? Because what's going to happen is x1 and x3 goes against clause 4 again, and we get just the x3 is left. This is new clause 3. And then we look at x3. This was forced by clause 2. And then we resolve new clause 3 against clause 2. x3 and not x3 eliminate, but we keep x1 and x2 in this iteration. That's new clause 4. You see where this is going? Now we're going to visit x1 and x2 again. And visiting x1 is going to eliminate x1. Visiting x2 is going to eliminate x2, but add x1 back in, and then we're going to eliminate x1 again. So the point is, we make this new clause, and we are iterating. And so what I need to think about is, what does it mean that we can find an empty clause? What is an empty clause? Like, an empty clause is sort of like, you know, if you have an empty list of variables, right? I kind of think that I see where this is going. So like, when you have a list of variables, and it's like a variable length list of variables, and you're going to OR them all together, what you're saying is, if any of these is true, then the whole thing is true. But that always leaves this weird question of, what if the list is empty? What does that evaluate to? And a natural thing to say is that it evaluates to false. Like the default assumption is false, because you're going to accumulate over the entire list, starting from false, and then switching to true if anything in there is true. So a good default assumption is that empty lists are kind of like false. I think that's kind of what this is relying on. This is saying something like that. So when we look at this, we're saying if this is not true, then the original clauses, right? If this derived resolved thing is not satisfiable, if it's going to be false, then the whole thing is going to have to be false. If it comes back empty, what that means is that we have two clauses that look like this. Yeah, if we have two clauses that look like this, and both of these clauses have to be true if the whole thing can be true. So basically we get to empty when we get to a point where there are two clauses that that either are original clauses or they're derived, but they're the derived clauses that say, like, look, you still have to be able to make this true if the whole thing can be true. Right? If it's possible for the whole thing to be true, these derived things can be true. So even if clause 1 and clause 2 look silly, they could be derived clauses that have to be true if the whole thing is true, and they can't both be true. And so, like, if we keep this iteration going, we're going to end up there, right? At x1 forced by clause 4, right? And we get one of these. And this is going to be just x2 now, and that's our new clause number 5. This is new clause number new clause number 4 and clause number 4. And then we look at x2, which was forced by clause 3. It's a new clause number 5 meets clause number 3. And the not x2 and the x2 collide, and all we get is the x1. And then finally, that x1 and the not x1 are going to collide in new clause 6 and unsat. Right? So look, new clause 6. If we got down to here and then in order for the whole thing to satisfy, this has to satisfy. And we got, in order for the whole thing to satisfy, this has to satisfy, and they zeroed out like that. Now, if I look at something, okay. If I look at something like this, what makes me nervous thinking about this is like, yes, I see that if it is unsatisfiable, then surely I will eventually discover an empty clause. But the converse is not necessarily obvious yet. It's not obvious that if I find an empty clause, that I didn't just set up a situation where I found an empty clause that could have been avoided through a different path. I still have to convince myself of that. That's where I'm struggling a little bit more. But it's at least clear now that unsat implies an empty clause will pop out of this iteration. So what's left is, why can't this pop up and just like eliminate out? Because this is not unsatisfiable, right? So if this is my whole problem, these are my two clauses, that's not unsatisfiable. I can set all of these to false and then I would fail, but all I have to do is set one of them to true, one of them to false, and the last one can be, there's more than one way to satisfy it. It's abundantly satisfiable. But if I were to put those two through conflict resolution, I would get an empty clause. So if I'm assuming the algorithm works, then there must be some reason why these two don't end up in conflict resolution with each other. So let's try to understand that. So let's just take a look at, in this case, where did the conflict come from in the first place? So here, when we look at this, we do propagation. Nothing will be forced to get set one way or the other. So then we'll take a guess. Let's say we took a look and we're like, yeah, we're going to guess that x1 is true. And then we're going to guess that x2 is true after that, because after x1 is true, nothing will propagate. Then we'll guess that x2 is true. Well, we wouldn't do that. All that would be left is to guess that x2 is false. Okay, so this example, I don't reach it, but I'm not getting a deep understanding of why I don't reach it. It's just kind of shallow, like, the first guess, nothing was forced, so whatever I picked, and then nothing propagated. Maybe it would be more interesting. Maybe it would be more interesting if something did propagate. Let me look at this. We look at this and we guess that x1 is true. So this is now satisfied. This then propagates, says x2 has to be false. But it all works. So the problem with this example, it doesn't even lead to a conflict. I need an idea of what can lead to a conflict. Like, how is conflict possible? Conflict is possible here because we have a series of propagations on variables that then creates a different clause. So a different clause ends up being false. So in order for this to work out, what I need is a way where I make a guess, because this was all forced by propagation. But if I made a guess that x1 was false, like here, or let me not change this one. Okay. x4, x5, x6. Let's engineer a thing that will create a conflict. x7. Okay. So the way we know this is going to create a conflict is that, just like before, it's going to determine to set x1 to false. But unlike before, here it set x1 to false because propagation, it's going to be forced to make x1 false by that clause. Here it's not forced, but it's going to look and go like, hey, look, there's a bunch of x1s. It's false more often than it's true. So let's guess that x1 is false. And then it's going to go, okay, x1 is false. So propagation makes x2 false. Propagation again makes x3 false, and we get a conflict. And so then when it goes to resolve the conflict, what will it find? Well, it's going to say, let's look at all the things that have x1. Oh, x1 wasn't actually forced. So that's not a conflict variable. That was a guess. Right, remember that part of the loop? Let me just pop back in there real quick. Conflict analyzer requires not just that we made the decision for this variable at the current point in the decision path. It also requires that it has this antecedent index that's not -1. This only becomes non-1 when it is forced into a particular value by propagation, not when we guessed the value. So we guessed x1, it's not a conflict variable. We look at x2. x2 was forced by propagation and was forced by clause 3. So then we take these two clauses, smoosh them together, and we find a new clause like this. Clause 1, clause 3, resolve becomes, let's see, x1 gets deduped, and x3 remains. Okay, we iterate this guy. x1, still not a conflict variable. x3, conflict variable. Who was responsible for fixing this conflict variable? Clause 2. So we smoosh them together. This will be new clause. I think I see where this is going. As soon as I started visualizing what I'm about to type, I think I see where this is going. New clause 1 resolves with clause 2 now. And so we get x1 stays, x2 stays, x3 annihilates, and we get new clause 2. Then we iterate. x2 is a conflict variable, so we resolve again against clause 3. New clause 2 versus clause 3. So when we took x1 or x2 and put it on this, all that got left was x1. Then we go, hey, no conflict variables. And now we have a new clause that we've learned that tells us some information. What does it tell us? It tells us that our guess that x1 would be false was wrong. So actually, x1 is going to be forced to be true from now on. And now that x1 is forced to be true, it will figure out that all of these need to be true and that the rest, and that's it. Now the model is satisfied. So a conflict happens because a conflict happens that does not lead to unsat. Means we made a guess, and that guess variable we're going to learn about. And the way we're going to learn about it is by looking at the clause that came out false and iteratively reducing that clause against other things that we know about those variables. So x2, what do we know about it? Well, we know that x2 had to be false because of this. x3, why that had to be false? It had to be false because of this. And so reducing this against these guys, we end up with the realization that x1 is going to have to be true. right? It couldn't have come out empty. Why? Why couldn't it have come out empty? If it had come out empty, what we're learning is let me read. Babbel's giving me some hints here, which I think I'm pretty much satisfied with my understanding. But there's some light bulb that I feel hasn't gone off. So no more guesses. Conflict happens when you have no more options. So no more guesses can be used to escape the situation. When I talked about a web before, the clauses are entangled, and if that means one cuts off another under unit propagation with nothing else for it to do, then those propagations from your initial guess wasn't going to work because it puts the clause in conflict. Yeah, I think that I pretty much have all the pieces at this point. What I'm trying to see here is, why is it that if I see an empty clause come out of conflict, the conflict analyzer, that I can conclude the whole thing's unsatisfiable, for sure, that there's no other way for it to come out empty. And what I'm kind of guessing is that this makes sense if I were to look at the loop code. Like if I looked at, let's write some pseudocode. So we have a clause, we'll call it the conflict clause. We do for each variable in the conflict clause. I get it. Okay, so here's what happens, right? As writing this loop was the right thing. Let me keep typing this in. So we get we have to say like if this variable let's use the let's use a name like if was constrained. So was constrained, what I mean is the variable got its value in the current decision step because it was constrained by some logic. So it wasn't a guess, it was constrained into this value. Then what we do is we do conflict if was constrained, let constraint clause equal, what is the constraint clause? It's if the variable was constrained, then this is the constraining clause of the variable, right? So whatever clause constrains that variable to a particular value. And then we do the conflict clause equals the constraint clause. And so up here we have a loop, which we'll call like the iterative resolve loop. And So the constraint clause becomes the resolve of the constraint clause, of the conflict clause with the constraint clause. So we have this thing where this is sort of like a limiting case kind of thing. We are iteratively looking at the clause over and over again and refining it down. And how are we refining it down? Refining it down by saying if there was two clauses that we put together, there's this transform where we make a new clause out of them that follows logically from the two clauses put together, such that the new clause will have to be satisfiable if the whole thing is satisfiable. And the only time... Oh, man. The new clause gives us... So what I'm kind of picturing here is the confusion I'm having is that the conflict clause is sort of like this is the one that came out false initially. And so once we start from there, we're saying this contains constraint that needs to be corrected. And so we can't guess freely. We have to make a change to our guesses that will not lead to this problem. The way we do that, then, is we look through all of the information we have about how we got backed into the corner where this clause became false. And all that information is tied up in this web that we're walking through. We're walking through a web because of the fact that each time we redo the iteration, we're starting with a new clause with possibly new variables in it. So that walks across potentially completely unrelated clauses to the original set of variables, potentially, over time. Not necessarily, but it could. And along the way, it's sort of unrolling the information that was in those clauses into... It's packing them all that information up into a new clause that contains the real reason why the conflict clause became false. Like, what did we learn about what has to be true to make this whole thing work that we didn't know about before, that will influence us to make different guesses, or will prevent or force propagation that we didn't have, and things like that. And the case of it coming out empty I'm just not seeing why. It's hard to find a reasoning for why it coming out empty is only possible if the whole thing is unsatisfiable. I'm just not spotting anything like that. It makes perfect sense why this moves you towards a solution, but it does not make perfect sense why we can know for sure that the whole thing is unsatisfiable if we can't find a non-empty, like if the conflict resolution comes out empty. I'm missing that still. It's rough. Let me bounce to the other piece real quick. So this part here is going to be why, or where we need to go back to. And we're unrolling all of the decisions that gave any values to the learned clause. Actually, we add to the clause, we backtrack. Something I find a little surprising in this code, in addition to all of this, is after we've learned the clause, we don't seem to run propagation first. I would think that after we learn a clause, we'd set back our decision level, and then we'd say like, hey, we have a clause we didn't have before. So last time we were here, we might get a different propagation result than we got before. And that's not here. And I don't know if that's just like an optional improvement that makes sense but isn't necessary, or if there's a reason why that is bad or not helpful. But it seems like it would be what I would expect, which is we learn a clause. The clause is the refinement of the information we got from the clause that evaluated to false. Is that true? So I thought like Babel in the chat is telling me that the new clause won't have any propagations. I thought like this example I looked at right here, I guess I deleted it. I thought this example right here had exactly that. I thought after we did propagation, or after we learned a clause from this, we learned x1, which would be something we could propagate, right? Right, so that's what I'm saying. Here, they learned the clause, so they add it to the formula. And here they backtrack. And then it loops back up and it makes a guess. I would have thought that after you learned a clause and you backtrack, that you would propagate first, based on how I understand it. Because like here, it guesses that x1 would be false. It then finds out that if x1 is false, that these can't be satisfied. So it smashes those together to learn this clause. Yeah, I can tell that it's not needed. So if the algorithm works, it works without what I'm saying. And it might be that it's not very common for this to immediately have something new. It's one new clause. I mean, you could say like maybe just run propagation on that one clause by itself if you really wanted to. But it seems like we could take all the things we know about like what we've guessed before this, plug them into the learned clause right then and there, and make sure that if there's anything that propagates that we didn't skip it. Oh, okay, I think I understand. The only thing I'm worried about, the reason I'm saying this, let me flip this around. I totally understand we don't need it, and it might actually make the algorithm more complicated as I'm thinking about it. But if we did it like this, then what we would learn is we would learn that x1 has to be false, right? And then if we were to backtrack and guess, we would guess that x1 is true again, wouldn't we? I mean, wouldn't this system look and go, oh, look, x1 is the most popular, and it's tied for trues and falses, so guess that it's true. And then we would, yeah, this is where I'm confused. How would this even go through the system and not be a bug? This feels like this would lead to a problem. So let me walk through the algorithm as I understand it, as it is written in the code that I'm looking at. It looks at this. So its first step is it can't propagate anything. I don't know what you mean by we re-enter a position in the graph. In the code I'm looking at, it looks like what would happen is the solver is going to pick a variable. It's going to pick, let's look at my example over here. It's going to pick guess x1 equals true. It's going to discover propagate. It's going to guess that x1 is true. It's going to propagate that x2 is false and that x3 is false. It's going to have a conflict on clause 1. It's going to learn the following clauses. So it's got a conflict on clause 1, looks at variable x2, smashes it together with this one, and we get not x1 or x3. And it's going to take that, and it's going to go, hey, x3, that smashes together with this, we get not x1 or x2. And it's going to take that, smash it together with this again, and learn not x1. Then it's going to go, okay, no more changes need to be made. This is what we learned. And then we add that into the thing up here. So we take learn from iteration 1 that we need to include this, right? Now, as far as I understand the code I'm looking at, it's then going to, since it doesn't propagate right away, it's going to guess. And when I look at how it guesses, I don't see any sign here that it would I don't see any sign here that it would know what decision it made on its previous guess. Again, I'm just looking at the code in front of me. Maybe what you're telling me is that there's a flaw in this, which is totally fine. pick a variable, assign a value to it, propagate, backtrack. You see here, there's nowhere in the mention of backtrack where it says now pick the other assignment for the variable. Yeah. Yeah. So it backtracks. I think it's going to then come up here and it's going to pick a variable. And the way it's going to pick a variable is it's going to guess that x1 is true again. And the reason it's going to do that is x1 is still the most common. Now there's a tie. And then it's going to find that this is false. Normally this would be avoided because if I put this formula in from scratch, right? If I took this formula and I gave it to the system, propagation would discover that x1 has to be false right up front. But if it modifies the formula here and then it doesn't run propagation, now it has the ability to pick a variable. You see what I'm saying? Isn't there a problem here? Now it has the possibility to pick a variable in such a way that it conflicts a clause without propagating. Okay, let me go read backtrack. If the value is not unassigned and the decision level here is less than or equal to the decision level here, we keep it. We unassign, it's unassigning the variables that came after the current decision level. So it looks like it's unassigning things. Heroin, I think I understand the implication that the new clause has to be true. There's a part of me that's having a hard time accepting that it's just as simple as empty clauses are clauses that can't be satisfied, because I imagine that I could put two clauses into the system for resolution and they would come out empty, but they could still be satisfied. So for instance, look, if, I'm not saying the whole algorithm would ever do this, but it's not as simple as just saying that if it comes out empty, then the two clauses aren't satisfied, because if I do resolve on x1, x2, x3 with not x1, not x2, not x3, then my understanding is that would create an empty clause. And yet these are totally satisfiable. So I understand that yes, a list of an empty clause cannot be satisfied, but that doesn't mean that if I put two clauses in that are themselves satisfiable, that what pops out can't be an empty clause. That's why I'm confused. This is what's confusing me, right? I understand that the empty clause can't be satisfied, and I understand that if I put in an empty clause and say I have this in the formula now, then that means the whole formula can't be satisfied. Maybe I'm understanding the resolve part incorrectly. I thought it would smash out and annihilate all of the variables that have opposite um, like that. Let me check that. That might be where things get weird. Resolve clause. So a resolve clause takes in two clauses. Yeah, Babel, I totally understand everything you're saying there. I understand that a false clause cannot be satisfied, and that if a false clause was part of the formula, that the whole thing would be false. What I'm talking about is from a different perspective. Despite the fact that that's all true, it's also true that the way I understand resolve is that these two clauses here would create an empty clause, but they're not unsatisfiable. So there's something about, it's not true to say that if I put in two clauses that can be satisfied, the thing I get back can't be empty. Unless I'm resolving incorrectly. Unless this isn't how resolve works. Right, so this is a part of it. All of this is saying this is true if we put two clauses in together that are in conflict. But I'm not really understanding what that means, because I don't understand how this isn't in conflict. So, like, here, these three clauses must be in conflict, right? I'm trying to understand how we're defining what it means for something to be in conflict, I guess. Because the way we discover what's in conflict is through this procedure of, hey, one of them is all false. And you could easily make one of these all false. Like, this could be false, false, false. So that can't, it's not the assignment. Setting a variable in one doesn't preclude the entire other clause. So these two are in conflict because setting a variable in one doesn't preclude the entire other clause. Yes, I understand that it can be satisfied, but that's not a useful enough definition for me to figure out what conflict means. Like, if we can discover conflicts at all, that's not the same as saying that the whole formula is unsatisfiable. It's unsatisfiable given some guesses we've made previously. And couldn't it be possible that some guesses and some how is it impossible that these two end up in conflict resolution, given that there could be other things in the same formula that created guesses and propagation so that one of them is fully false, right? So like somehow x1, x2, and x3 are all false, and they got forced to be false. Well, if they got forced to be false, then this couldn't be the antecedent clause. That makes more sense. For the one on the right has to be an antecedent clause, which means that one of its variables must be the only true variable. Okay, so resolve makes sense when we say the one on the left is all false, and the one on the right has one true variable, and the rest are false. Or one true literal, and the rest are false. So let's take this case, because we know that in this process here, clause 1 and clause 3 end up in conflict. This one turns out to be all false. This one is an antecedent. This is all false. We go, hey, I'm looking at variable x2 here and wondering what you know about that. And it's saying, oh, well, yeah, I forced variable x2. I am antecedent for x2. What we mean is x2 is the only true variable in this one. So x2 had to be this way. x2 had to be true, false, so that I could be true. And he's going, but all of my variables are false, so they are in conflict. He needs it to be true. He needs x2 to be false. He needs x2 to be true. So then, when we smash them together, we get x1 or x3. And what we've computed there, is how we need to think about the other variables. So not this conflict variable. X2 is the conflict variable. We've computed a formula that tells us, or a clause that tells us, what we need to do with the other variables so that these clauses can actually work together. Because trying to make them work together through the x2 variable wasn't going to work. And when we repeat this until we find a clause that doesn't have conflict with any other clauses, right? So this is going to have conflict again, and it's going to have conflict with this one now, right? It's going to go, all right, I'm still in a situation where I've got this variable x3 that was a problem recent, like in this, there's a problem here, and you made x3 false, so I still have conflict with you. And then it figures out, okay, in order for these two to get along, we can't rely on x3. So it takes x3 out of the picture. But from the perspective of this, it says, well, one way we could solve this is if x2 is true. So it adds that back in. And then it has to go through one more resolution to remember, like, this is still a variable that can fall into conflict with this clause here. And so it goes again. And so when it stops finding more conflicts, it means that it has a clause where none of the variables that are left are ones that are the only true variable in their clause. And that's why if I have an empty list at the end, then it means I couldn't find any way to make all of the clauses true because I've eliminated all the variables that have to be true for a particular clause to work out, and left behind the variables that can be adjusted to resolve the conflict. Basically, this is saying this is the guide. This new clause is like our guide to avoiding conflict between these clauses in the future. It says use this to figure it out. If it's empty, then it's giving you there's nothing you can do to figure it out. Yeah. Harrowin, I'm hearing you, but um I'm not so sure, because that's just not what the code that I'm looking at is doing. So part of this might be that I'm reading code that uses funky tricks you shouldn't be using, but I think more likely it's that we're talking past each other a little bit. So if I look at this resolve function here, I think, I don't know for sure, but I think yeah, anytime it finds two literals that cancel each other out, so a positive and negative that add up to 0. Then we remove that. It doesn't say if, so the literal here is computed here in the loop. It's across the entire set of duplicates. There's no special literal that we are eliminating from both. It is eliminating all of the literals that are opposites of each other. Now maybe this is like extra garbage that isn't necessary. Gotcha. So, gotcha. Harrowwind is telling us the way to think about it is that when we find a pair of clauses that are in conflict, we do that with respect to a particular variable, and we resolve them by smashing the clauses together and eliminating the particular variable that's in conflict. The code we're looking at is sort of preemptively doing it all in one step. And the reason that's confusing to me is because I'm then predicting, like, wouldn't we get into cases like this? I've eliminated it. I've erased it again. The case, the confusing case is if you resolved x1, x2, x3 with not x1, not x2, not x3. But this is impossible. It's not impossible to pass that into the resolve function, but it is impossible for the algorithm as a whole to get into the situation where it would resolve those. Because as I was saying, in order to get here, we have to have a situation where this clause is fully false and this clause... Well, that's a good question. I have to go back and check something. This clause is fully false. This clause has almost fully false, but one true. So it's like they're both bound up. And there's no way to make them both happy because this one has one true variable, and that variable needs to flip so that this one could be true, but then this one would be false. We get in a situation where we have a false clause and a bunch of clauses that are related, where if I flip a variable in the false clause to make it work, some other clause becomes false, right? And so this can never happen in the... You could put this into the resolve function, but that they wrote in their code, but you never would using the solver loop. Now this part still bugs me. I want to get back to that, but the The thing I think I want to do is I'm going to wrap up in the next 10 or 15 minutes by switching over to Minisat and see if I can build that. And maybe then if I stream again, we can do some building of Minisat. But I think I'm satisfied with this. There's one more logical thing I want to think through. I'm not going to pay attention to this because I suspect that if I could build the code and put this in there, that would answer my questions. And so it's a little frustrating. But the thing I still want to understand is after a resolve, let's not think about the confusing case. Think about the good case of a resolve. Is it true? So here we have clause 1 and clause 4 in conflict. Clause 1 was the one that came out all false because we found a conflict on clause 1 after we assigned, let's simplify this here, x1, x2, x3. So propagation sets all of these false. That gets false, that gets false, that gets false. We find out this is false, we have a problem. It then goes, resolve these two. I want to know, does the new clause have the same property that the original clause does, which is that it's false? So say this is false and this is true with exactly one variable. With exactly one of its literals, right? Then when we do the resolution, yeah, the new thing would still be false. And the reason is all of the literals from this are still present. All of the literals from this that weren't the true one are present. Right? At least that's the way Harrowin told us to think about it. If we look at the code, there'd be fewer things present, but fewer things present can't make it true. So even if it didn't eliminate other duplicates or other conflicts or other, it didn't annihilate other literals, it did give us a subset of what it would have done if it had done that, right? It's only fewer literals than that amount. So this one is still all false, right? It's like the whole clause is still false. So by the time we're done resolving, we still get a clause. Let's look at this case. We guessed x1 was true. We get a clause. By the time we're done, the clause we got is still false. But it's a clause we didn't have before that we're hoping will guide our guesses differently. The only thing I'm not satisfied with is either there's a bug in this code or I'm just reading something wrong. I'm convinced that if I look at this solver here, it does propagation at the beginning, it picks a variable, it assigns that guess, runs propagation. If it finds a conflict, it learns a new clause, and then it backtracks. It backtracks far enough up that it doesn't contain any of the guesses that lead to the values we had in that clause. So the new clause we got, right, if you look over here, it's like this. It backtracks to a point where this variable is no longer fixed. It goes back to being unassigned. Right? So it does a backtrack. It goes from x1 being true by guess to x1 being unassigned. My concern is that with this code, the next thing it does, since it doesn't propagate again, it backtracks and then it goes and gets a guess. And there's nothing in the guess is just derived from all the variables. Right? There's nothing in here saying if we've done a backtrack, don't guess the same thing or anything like that. I think that's definitely wrong. At the very least, it shouldn't ever make the same guess again. Because if it makes a guess, and then it might have backtracked farther, right? It's possible that it does farther backtrack. So you wouldn't necessarily want to say, don't set... I set foo to true a moment ago, and then I unrolled back farther than before foo was true to other guesses I unrolled. So now it might be valid for foo to be true again, because foo being true isn't the only thing I've unrolled. I've unrolled everything connected to the learned clause. So the only question is, and it sounds like Babel is still telling me that there's something I'm missing about the variable picking. Yeah, look at those. We look at all the clauses. The conflict means we've learned that it doesn't contribute to satisfaction and can be ignored from now on. I don't know what it is in that sentence. Babel says we go all the way back to our first guess involved in the conflict, because the conflict means we've learned that our first guess, doesn't contribute to satisfaction and can be ignored from now on. So the first guess in the conflict, we roll it back. But is there anything to stop us? Like, surely the next thing we do shouldn't be to make the same guess again, right? I'm correct in saying that we shouldn't roll something back and then make the same guess we did the first time we visited. Okay, so we don't want to do that. How is that impossible? I'm looking at this thinking that is possible. We ignore it. We ignore the variable? How does it ignore the variable? It looks to me like it would mark the variable as unassigned and keep working with it. Right, so the relevant things are the solver does the backtrack. The backtrack goes, well, weirdly, the backtrack goes and unrolls everything up to that decision level, but not before. Like, it doesn't unroll, that's not what I meant to say. The weird thing is it uses less than or equal to here, so all right. So in this example that I cooked up, it would originally guess that it's x1. And you're saying that it's going to ignore the variable, but I would have thought that the next thing it would do is determine that its guess of x1 was wrong, and so it would have to guess that x1 is false. Yeah, I'm bouncing back and forth between some things. Let's look at just this example and forget the code for a minute. As I understand it, after it makes the guess that x1 is true, it would add this clause, and it would be correct to say that we have, at least in this case, it would be correct to say that we have learned x1 has to be false. I suspect that in other cases it might be that we can't deduce that. Like if we had several guesses that were both several levels of decision, several guesses that were all wrapped up in the newly learned clause, then all we would have learned is that that combination of guesses doesn't work. And when we roll back, we might start with a different guess. But that doesn't mean we can say that we know what the first guess is supposed to turn out to be. right? If I make more than, is it possible for me to make more than one guess and unroll more than one guess? Because what I've learned is that collection of guesses doesn't work. Look at the variables, he says. Their negation is inside the clauses. Yeah. I think I'm getting lost with what you're saying. I don't know what the tuplets of like the four element tuplets are about. I don't know if this is in reference to a specific example or a general example that I'm not picturing. I don't know what you mean by because anything false inside the clause becomes true and true becomes false. I'm missing what you're talking about somehow. Anyway, I still just don't get how it's possible that this is picking a different guess for the variable. It seems to me like it's going to pick the same guess. That's the part I'm stuck on. I don't know if it's that I'm reading the code wrong or if the code is wrong, but it seems to me like it would, in this case, it looks at all this, like just thinking literally about what the code does. It looks at all this, guesses x1 is true, learns this clause, unrolls its guesses, and then guesses that x1 is true again. Yeah, I haven't read about this too much yet. I mean, I know a little bit about it, but I do plan on reading a few things about it as I go farther with it. But today I was just hoping to get some practice reading code and learning from written code. And yeah, I might not have picked the highest quality code ever for that purpose, but that's part of the real world challenge of reading code anyway. So I'll definitely be getting into that if I spend more time on this topic. Okay, this is an interesting statement that I don't understand what you're talking about. Because, Babel's saying, because we do the unit propagation, we know that changing from x1 equals true to x1 equals false would end up with a complementary unit propagation that still works. What do you mean that still works? What's confusing to me is you're saying things like it still works or it works either way, when the whole point is it didn't work the first way. It's like I feel like you're talking about something different than what I'm thinking, where we're using the words in different ways. I'm not talking about conflicts right now. So this is where maybe we're not talking about the same thing. Looking at, if you can see what's on my screen, it will help. These clauses here would lead to a guess. It'll lead to the guess that x1 is true. Now these clauses are satisfiable, but not if you set x1 to true. So it leads to a conflict. And so it is important if x1 is true or false. That's what I'm saying. Right? Like it won't work if x1 is true. And so when we guess that x1 is true, we then go through conflict resolution. We learn a new clause. That new clause literally tells us that x1 needs to be false. You're saying it isn't important if x1 is true or false with respect to what? Obviously, it's still important if x1 is true or false to get the whole formula to be satisfied. But you're saying it's not important if x1 is true or false in the sense that we're eliminating x1, but we're not. It's like even when we go and do conflict resolution, x1 isn't the variable we're talking about eliminating. So if we're talking about taking conflict resolution perspective, x2 and x3 are the variables in conflict. x1 is the guess. x1 never shows up in conflict. Right? And what I'm talking about here is like I think I am not worried about conflict resolution here. I am worried about what happens after we've learned a clause. So we're done and we backtrack. I don't see anything in here because you say that like when you backtrack you take the opposite decision or it doesn't matter or things like this. But what I'm seeing is code where it would make the exact same guess. And I'm trying to understand if that's really what the code does or if I'm missing something. And I want... sorry, I'm coming across a little frustrated now because I'd kind of like to wrap up, but I'm still puzzling at this. Yep, okay. Harwind, I'll answer for you. So it does unit propagation, but let me show you the whole loop. So if you're looking here, here's our solve loop. It starts with propagation. So I agree when it propagates. If we started with this clause in the mix at the beginning of the solve, it would take care of that. It then starts this loop of going, okay, make a guess and assign that guess into the model. Propagate again, and so that's all fine. If we started with this is where it would make a guess. It would make a guess by saying x1, let's make that true. It assigns that in, and it runs propagation. When it runs propagation, it learns that x2 is going to have to be false, that x3 is going to have to be false, and then it finds a conflict, resolves the conflict between all of these things that it just propagated through, and learns that x1 has to be false. It adds that to the system down here, right? Takes the learned clause, adds it in, and then it backtracks. So it removes its guess that x1 is true. So it's removed the guess that x1 is true, and what does it do next? It comes back to the top and makes a new guess. It does not propagate. And that's what I'm saying. I feel like that's the mistake. It seems to me like after you've added a formula, you would need to run propagation again. At least you would need to check if the newly added clause causes any reductions. Because if you don't, you could just go and guess that x1 is true again. And that's what I think this code does. Unless I'm missing something, I think it goes, x1 is the most popular variable. Since there are as many trues as falses, it will pick true for x1 again. And then it'll find a conflict here, and that conflict won't even contain any real conflict. I think that maybe I'm just pointing out that there's a bug in this code, but I'm trying to say, wouldn't it be important that either you run propagation on the formula after you've changed it before you make another guess, or that you have specific logic to ensure you don't make the same guess? Wouldn't you need at least one of those things? I guess I didn't read formula add clause. Maybe it does more work than I'm giving it credit for. No. I don't think backtrack does anything fancy. Yeah, it just takes out all the unassigned variables from higher decision levels. Anyway, I think I'm gonna wrap up with this and try to build minisat for a minute, and then we can be done for today. So I got let's see here. I need to pull up this one. Open my build. So when I run it, problem I run into is zlib.h. Okay, so how can I get this? I want to pop it over here. Let me pull it over here real quick. Software. Yeah, here we go. Extract here. Oh wait, that's right. It doesn't work that way. Open archive. Boom. Extract. Okay. There we go. Oh. Yeah, it feels like either the code I'm looking at has a simple trick that just makes it work, or it's a small oversight for an unusual case that I can't test since I can't build the code. So it's a little confusing, but I think I'm satisfied that I get how the CDCL solver works. So yeah, we're gonna try to build zlib, I guess. How do I want to do this? I guess I'll just drop it straight in. It's not exactly how I would like to do it, but yeah. Zlib, there we go. zlib .h include zlib. All right, so that's how I build solver. Let me go grab one of these things. Sat. Okay. What? Why is it only building those three? What is going on? Okay. Not. Oh, right. Okay, they've got CPP files and CC files. I'm gonna need to do it like this probably. And I bet you zlib. Yeah, it's got C files too. No idea. No idea. Okay. I don't want to be building zlib yet. So let's minisat. Core main solver, MTL is just a bunch of headers, simp is main and simp solver, utils is options and system. Okay, yeah. So those are the minisat files. Maybe I'm not going to build before the end of the stream, but let's just give it a shot. Okay, so this doesn't build on Windows, or do I need to... Do I need to build differently? How am I supposed to... Yeah, let me... Thanks for sending me a link. I got... Where did you send that? I'll check out your build script. I'd rather do that than do whatever I'm doing. I'm not someone who should be trying to figure out how to build something. I'm so bad. I'm so bad at dealing with build systems and things. So it's in a whisper. I don't see a whisper from you, Bitwitch. Oh, wait, yes I do. There we go. Oh, awesome. Okay, let's try this. See what you did. Fair. Okay, yeah, let's try this. So my zlibdir is gonna be like search sat mini sat 220 zlib. Okay. Add spaces around. Okay, so you had to do this too. Yeah. Okay. Mini sat. Got some flags here that I probably need. All right, let's give it a shot. Oh my. We found a forecoder crash. Okay, worked this time, or it didn't crash this time, but what do we, what now? Okay, so it's not finding stuff in its folders. So we should, let's open all code, pull up the build.bat. Let me just say, don't go this far, echo surster. Don't we need to do like surster? What options apply to entire command line? Why are we not getting no logo? Oh, there's a CL up here maybe? Maybe it's the end make? Might be this that's printing the logo. Okay. Command line warning. Options apply to entire command line. What are you talking about? Well, I don't care. It doesn't seem like a problem. Whatever. Yeah, this doesn't look like it's gonna build because, like, there's still Linux stuff in here. I probably have the wrong minisat code or something. I didn't find minisat on GitHub. I couldn't find it on GitHub. I'm just okay. Here we go. I went to, let's see, popped in here. We go to minisat, and they're like, here's the minisat page, and you're like, okay, I guess I got this. I don't know. Where did we find? I guess we found a GitHub earlier. Yeah, let's try to get this one. Yes, let me just, okay. Just doesn't matter. Just close, it doesn't matter. We're going to, let's see here. We're gonna pop in here, grab our copy of zlib, pop it right there, minisat's gonna go away, and we're gonna git clone this. Let's try it this way. Okay. Zlib 1.3. All right. And then we want to grab that gist again. Here's the gist from Bitwitch. Fix this, we just have to type in someday. Boom. Well, this is different, so we've confirmed the GitHub version is different. Okay, so this is not unexpected. The GitHub version is different for some reason, but also, so this needs to be a bool. Hey, there we go. Does that mean that, like, it worked? Do we have, hey, cool. All right, I'm gonna stop there. Thank you so much, Bitwitch, for helping me build that. Thank you to Babel and Horrorwind for holding my hand through some of the the difficulties of understanding the CDCL solver. I'm gonna keep this going. I enjoyed this. I think next time we will walk through some minisat, maybe try to read minisat the same way we did with the CDCL solver and see what we learn there. Minisat's a C++ project instead of a C project, so I'm gonna have certain um, pet peeves coming up more often, and on the other hand, I'm also thinking it might be better code. And the reason I say that is because Minisat is like this. When I look at the structure of it, it just gives me this impression that it is nice, small, directly solving the problem in good ways in a lot of cases. So I'm excited to see that. Make sure to join me next time if you want to see more of me reading code and trying to make sense out of C++ this time, which can be difficult, but I think in this case at least it will be rewarding since I think it's probably a cool tool to understand better. So yeah, if you want to, by the way, I do have a Discord channel. I'm gonna drop a link for everyone who's here who might not know about it. I have a Discord server for like long-term conversation about programming and stuff. So yeah, let me grab that invite link wherever it is. Should just have one of these saved in my favorites or something for the future. But yeah, here's an invite link to my Discord. If you're not already there, you can come hang out. We have like a forum kind of structure where people can post questions and threads and talk about things. And on top of that, well, I have nothing to promote on top of that. But let's see if we can't find a interesting programmer on Twitch for me to raid when I sign off. Let's see if there are any good. It might be hard to find a super computer sciencey thing like SAT solver, but we can find like some. I'm actually not finding a whole lot. There's like a couple of streams. I might also be using Twitch incorrectly. That's extremely likely, but it's like very short list of people who are live, so these are like music streams. I don't know how to search for people who are actually programming something. Hold on. Alright, I might have to practice this and do it some other time. I gotta sign off because my head's getting all fuzzy and sleepy. Yeah, I typed in programming, but I don't think I'm supposed to use the search. It's like here's the search for programming. That's a Twitch channel. I'm on Twitch TV/programming now. I don't know what I'm doing. It's so confusing to me how little I'm seeing. Software and game development. Okay, maybe that is what I should look at. Yes, this is now I actually have like the tiles, the grid of tiles, which is what I thought I was looking for. Yeah. There is the additional challenge that I don't know how to raid somebody. Let's see. A command in the chat, huh? So I go to their chat and I go, wow, this is tough. Twitch is hard, man. All right, Twitch, how to raid. Use my search engine. How to use raids. To start a raid, type /raid, followed by the name of the channel you wish to raid. Okay, so I type in my channel. All right, I'm going to sign off. Thanks, everyone, for hanging out.